Welcome to another Software Engineering for Geniuses video. How professional C programmers code FizzBuzz. FizzBuzz is a programming challenge based on an English children's game introduced to the programming community by Imran Ghory in a blog post back in 2007. When I completed the challenge, this was the resulting code. No if statements, no switch statements, not even a ternary operator. I needed only a two-dimensional array to correctly categorize the numbers. Now I'll show you two different solutions which will do the trick. One with a roundhouse pattern, and the other one shown here, the control data array. To tackle the challenge, first I needed to define the requirements it poses. 1. Print numbers 1 to 100. Unless it's a multiple of 3, in which case we print fizz. Unless it's a multiple of 5, in which case we print buzz. Or unless it's a multiple of both 3 and 5, in which case we print FizzBuzz. To make certain I came up with the correct solution, I analyzed the requirements. First, we see that the program should print out the numbers 1 to 100. But the next three requirements set conditions on that, making it somewhat more complicated. So I simplify the requirements so they're clear and will make my code cleaner. Expressed in this manner, I have a main requirement and 4 subordinates. I therefore redefine the requirements. 1. Iterate our numbers from 1 to 100 inclusive. A. Either the number is a multiple of 3, in which case we print fizz. B. Or the number is a multiple of 5, in which case we print buzz. C. Or it's a multiple of both 3 and 5, in which case we print FizzBuzz. And D. Or we merely print the number. Expressed this way, I have a main requirement and 4 subordinates. And the subordinates don't complicate the main requirement. Well then, so the redefined requirements look like they still match the challenge posed to us. So the main requirement is to iterate over the numbers, which I'll do in a control loop. And the 4 subordinate requirements we see have 1 entry point and 1 exit. They are mutually exclusive. So I coalesce them into a control function at first, so they're encapsulated from the control loop, and I can work on them separately after the control loop is finished and working correctly. Now I can begin writing code. I'll begin with the control loop. Then invoke the routing function and wrap it all in a main. But the routing function still needs to be defined, which I'll stub up for now to print the parameter and make certain the program will actually iterate over the numbers correctly. Now that I'm convinced the control loop was coded correctly, I'll begin the next development iteration. Returning to the analysis phase, I examine the subordinate requirements which will be coalesced into the router function. So I examine the requirements and see that they're mutually exclusive. And to make certain I distinguish between the conditions by which they're executed, I'll write up a truth table with those conditions in the columns, and I'll fill the correct values into the rows. In the first state, the number is a multiple of 3, and not a multiple of 5, in which case we print fizz. In the second state, the number is a multiple of 5 and not a multiple of 3, in which case we print buzz. In the next state, the number is a multiple of both 3 and 5, in which case we print FizzBuzz. And in the final state, the number is neither divisible by 3 nor by 5, and we merely print the number. Since I have a truth table with simple states and values, and the routing function only needs one entry and one exit with the 4 subordinate requirements, I've decided to use the roundhouse pattern, which makes the code simple to design, code, and verify. The truth table has 2 input variables, each with 2 possible values, giving us a 2-dimensional array with 2 elements each of pointers to functions. Then I derive the control variables and the functions for the roundhouse array. Now I can begin to code the functions. I begin with the 4 data processing functions, which are the targets of the roundhouse. Then I define and populate the roundhouse array. Then finally I update the definition for the routing function with the roundhouse code. And that is how FizzBuzz is coded using normal professional practices. And it would be satisfactory if this were a normal app which would see continued expansion and maintenance. We would add on to the target functions, and we might not need to alter the structure of the control loop nor the roundhouse. But in the case of FizzBuzz, we merely desire to use these rules to print out these results. So I'm going to show you a simpler design which still meets the requirements. Going back to the analysis I did before, and the truth table it generated, we can see it's completely the same, just for review. Now the requirement that the app print one of all statements for each number means I'll have code that looks like this, and the odd one among them is the one that merely prints the number because I pass it as an argument to printf. Well, the good thing is that printf doesn't do anything with the parameters it receives if it isn't included in the formatting string. So I can pass the number as a parameter in all 4 cases, knowing printf will do the right thing and ignore it when it isn't needed. So with that in mind, I derive the control data array from the truth table. So now to code it, I define and populate the control data array, and add the preamble and constants the app will use. Then code main with the control loop, and the rules and the printf statement which will use the formatted string specified by the control data array. And that is how professional C programmers truly code FizzBuzz. Thank you so much for watching this Software Engineering for Geniuses video. I hope you found it to be informative and helpful in expanding your catalog of design ideas. I should be very interested in hearing of alternative design choices, ideas, and remarks in the comments below. And I hope you click on like, subscribe, and the bell below to be notified of future videos.